Now that we have our mole map up in this corner over here, we're going to be able to utilize it so that we can do our molar conversions. Now, two-step molar conversions, how do I know this is a two-step problem? Well, the problem itself is never going to mention mole, but the mole is the center of our molar conversion universe. So in your problem, no matter where you start, if we start in liters and we want to go to, let's say, mass, or we want to go to particles, we have to go through the mole. So let's go ahead and get started by solving some of these problems. So the first question asks, what is the mass of 4.22 times 10 to the 15th atoms of uranium? So we need to identify our given, what we're starting with. So our given is here. We're starting with atoms of uranium, which is a type of particle. So I'm starting here, and I'm going to solve for mass. Mass is gram. Now remember this molar mass here, this would be the number that goes in front of my unit, which is gram. Just like I have 6.02 times 10 to the 23rd in front of my particle, and 22.4 in front of liter. So we're going to go ahead and we're going to set up our fence here. So I'm going to start with my given, 4.22 times 10 to the 15th atoms. And instead of writing uranium, I'm going to use the chemical symbol. I'm going to say U. And I'm setting up my fence. So I know that I'm not staying in atoms. I want to go to mass, but unfortunately I don't have a direct route from particle here to my mass. I don't have a road that connects these two. I have to go from particle to mole, and then from mole to mass. So I have to take this two-step route, particle to mole, and then mole to mass. So I'm going to take my atom unit down, because I don't want this in my answer. So to get rid of it, I'm going to bring it down. We're going to bring atom, U, and since I'm solving for, in this step, mole, I'm going to bring mole up top, mole of U. Now, I know in front of mole, I have 1. It's always going to be 1. In front of atom, well, this is a type of particle, so I've got 6.02 times 10 to the 23rd. Now, if this was a one-step fence and I was just solving for mole, I would stop right there. But I'm not solving for mole, I'm solving for mass. So I need to continue on. So I'm going to go to mass. So now I need a step going mole to mass. So I'm going to bring mole down, because whatever's upstairs comes downstairs. So mole U, and 1 mole of U. And I'm going to mass, where my unit is gram of U. Now this is where I need my periodic table. And my periodic table is going to tell me that my molar mass, which is the mass from the periodic table, so my molar mass for U is 238.029. So I always go to 2 decimal places, so 0.03 grams. So now we're going to multiply. Now remember, this stuff belongs up here, so this is part of my mole map. I know it kind of bleeds in. Okay, so now what I'm going to do is I'm going to go ahead and set up my multiplication and division. So I've got 4.22 times 10 to the 15th. I'm going to multiply times 1, and then multiply again times 238.03, or 238.03. Enter, just to keep my life a little bit easier. Then I'm going to divide that answer by, and this is a trick you have to pay attention to. Whenever you're dividing by something in scientific notation, you need to put it in parentheses. So I'm just going to put everything in parentheses here, 6.02 times 10 to the 23rd. And then if I divide again by 1, I'm still going to get my answer. So this is my answer in the calculator, so 1.6685 and some more change times 10 to the negative 6th. But I have 3 significant figures here, 1, 2, 3, so I need to round this to 3 significant figures. So I'm going to take 1.6, and then this second 6 here is going to round up to a 7 because of the 8. So it's going to be 1.67 times 10 to the negative 6th, remembering this part right here, grams of uranium. And that's going to be my answer for my 2-step problem. There. So let's go ahead and do another one. So this next question is asking how many atoms are present in 6.2 liters of helium gas at STP. When we see this STP, it doesn't change anything. I know I'm just going to be using the 22.4 as my conversion factor. So I'm starting with 6.2 liters of helium gas, and I'm going to atom, and atom is a type of particle. So looking at my mole map, I'm going from liter to mole to particle, and my particle could be atoms, it could be molecules, in this case it's atoms. So I've got 6.2 liters of helium starting out my fence. I'm going to continue my fence here. Because I don't want liters in my answer, I need to divide by it. So whatever's upstairs unit comes downstairs. I'm going to put in liter of helium, and then I'm going liter here to mole. So mole comes here, and this is mole of helium. I have 1 mole of helium, because it's 1 mole here, is 22.4 liters. Now a lot of people just want to throw the numbers in, they don't want to leave the space, but I always write my units first, because the number doesn't matter if you don't know where it goes. If you put it in the wrong place, it's not going to work for you anyway. So I always do my units first in that section. So this is going to go from liter to mole. But remember, I'm solving for atoms, so how many atoms? So now I need another step going from mole to particle. Well, what I'm coming from goes on the bottom, mole of helium, and I'm going to atoms of helium. So 1 mole of helium has 6.02 times 10 to the 23rd atoms. So now this is multiplication. So I'm going to have 6.2 times 1 times 6.02 times 10 to the 23rd. Enter. So that's my top half. Then I'm going to divide my answer by 22.4. Now here I got 1.666 times 10 to the 23rd. I go back and I double check. My starting number had 2 significant figures, 1, 2. So I need to round this to 2 significant figures. So I'm going to get 1.7 times 10 to the 23rd atom of helium. That's my next answer. And then I'm going to do one more problem so you guys can see. And this one's going to involve gram. So I'm starting with 150 grams of carbon dioxide, and I'm going to volume. So I'm going from mass to mole to liter. Mass to mole to liter. So we're going to start with our 150 grams of CO2 carbon dioxide. Then my gram comes down, because whatever's upstairs comes downstairs. So gram of CO2 comes down, and mole of CO2 goes up, because my first step is gram to mole. Whatever I'm solving for goes on the top. So I know 1 mole of CO2 has a molar mass of, Well, we've got 16 plus 16 plus 12.01, 44.01 grams of CO2. But I don't want to stop at mole. I'm going to liters because we're at STP and we're going for volume. So I'm going to bring mole down, 1 mole of CO2. And up top, I'm going to bring liter of CO2. And I'm going to put 22.4 in front. So now I'm going to have 150 times 1 times 22.4. And I'm going to divide that by 44.01. Now, this number that I started out with has 2 significant figures. This 0 is not significant because I do not have a decimal written in the number. If I had a decimal point after that 0, then the 0 would be significant. But because I don't, only the 1 and the 5 are significant digits, I need to round to 2 significant digits. So I have 76.3, well, that stays 76 liters of CO2. And for all of these problems, notice I have a number, I have a unit, and I have a name. I've got my number, I've got my unit, I've got my name. My number, my unit, my name. It's really, really important to make sure that you include that because later we are going to be doing more complicated problems that are going to involve a lot of different compounds in them. And so it's important that you know which compound you're working with as you go, which is why I write CO2 in every single box for this problem, and it's why I write helium in every single box for this problem. So that is 2-step conversions. The remaining 3 problems that we did in class were practice, so please try those on your own, and then if you are absent, come and show me your problems so that I can check your work and we can talk about what happened and what went right and what didn't go well.